We're going to talk today about something called special angles, and these are angles that we tend to focus on in pre-calc when we apply them to trigonometric type problems. So the angles that we refer to, and what I'm going to do is, let me just make a chart, and this is something that you can put at the top of your page every single time you have a test or a quiz, or you're doing any kind of homework, and it's kind of like a tic-tac-toe board. So just like that. Okay. So the special angles are 30 degrees, 45 degrees, and 60 degrees. Okay, now remember though, we have just finished going over degrees to radians, radians to degrees. You're not going to see them written as 30, 45, and 60. So remember that 30 degrees is really pi over 6. That, what do we have? 60 degrees is pi over 3. And then the last one is 45 degrees, which is pi over 4. Okay? And again, just as a little bit of a review, the way I like to remember it is there's always going to be a 3 with a 6. Same thing here, a 3 with a 6. So 30 would never be pi over 3 because that would be two 3's together. Just like 60 would never be pi over 6 because then you'd have two 6's together. So it's always a 3 with a 6 and a 3 with a 6. And then 45, well, I think that's kind of easy because you have a 4 in it and that's got a 4 in it. So that's just an easy way, I think, to remember it. All right, so now the rest of this chart, getting back to that, is remember good old-fashioned SOHCAHTOA. And so the left side of this chart goes in SOHCAHTOA order. So we're going to put sine first, so, then ka, which is cosine, and then toa, which is tangent. All right, so we're going to basically assign values for these trig functions. So for example, the sine of 30, we're going to have a value here, and that would be what the sine of 30 is equivalent to. If I wanted like the cosine of 45, I would just look here at 45, I would look here at cosine, follow it out, and the value for the cosine of 45 will be here, and so on. Okay, so let's just start putting them in. All right, so there's a really easy way, I think, to do these. So basically all you do is, they're all going to be fractions, by the way, except for two of them. So to start, I would just do 1, 2, 3, like you count, right? And then in the second row, we're going to do the opposite, 3, 2, 1. So 1, 2, 3, 3, 2, 1. Then, like I said, these are all going to be fractions. So we put fraction bars or lines, whatever, and every single one of these denominators is going to be a 2, every single one. Okay, so I'm going to just stop real quick because I want to make sure that you get the pattern, because then this is really actually very easy. 1, 2, 3, 3, 2, 1, and then all the denominators have 2's. Okay, all right, now every single numerator is going to get a radical. So I could put, let me just talk about this for a quick second. I could put a radical here, but what's the square root of 1? It's 1, right? So I tend not to put the radical here because I simplify it in my head and say, well, the square root of 1 is 1, so let me just put a 1 here. If you put the square root there, it's not wrong. You can, it just kind of looks weird. So then every numerator gets a radical. Every numerator gets a radical. Except, like I said, for the ones, which you can put them, I'm not going to. So, really easy way to remember it, right? 1, 2, 3, 3, 2, 1. All the denominators get 2's. All the numerators get radicals. I just simplify the radical ones. Okay, so then lastly, let's look at this last row, which isn't as easy to memorize, but this is the way I remember it. I put a big old 1 right smack dab in the middle. Okay, and then the two empty boxes on the bottom left and the bottom right, they both get a radical 3. So a big 1 in the middle, and radical 3's on the left and the right. Now here's the only exception. Since this radical 3 is associated with 30 degrees, and this radical 3 is associated with 60 degrees, since this 30 has a 3 in it, this is the way I remember it anyway, this guy gets an extra 3. Okay, so we get an extra 3 in the denominator of the angle that corresponds with this value. Because there's a 3 in that, that gets an extra 3. There is not a 3 in this, that does not get the extra 3. Now, if you have another way of remembering it, go for it. Okay, so we're going to use these special angles when you come back to class. And like I said, you're going to definitely have to memorize these. The quicker that you memorize them, the easier it's going to be for you. You can write the table at the top, but it also makes sense to memorize them. Now, I want to just show you a couple of other things. Do you notice that the sine of 30 is the same as the cosine of 60? Sine of 30 and cosine of 60 are both 1/2. And look at this, the cosine of 30 and the sine of 60, they're both radical 3/2. That will always be the case. I mean, none of this is ever going to change. So if you want to remember it that way, sine of 30, cosine of 60 are the same, and reverse. Cosine of 30, cosine of 60 are the same. And then notice that the sine and the cosine of 45 are always the same. All right? All right, the next thing that we're going to talk about is something called the unit circle. So this is the unit circle. And you probably did this a little bit in Algebra 2 is my thought, but I know there was a crazy little pandemic going on, so how much you took away from that, I'm not really sure, so we're going to redo it. So the unit circle, just think of what the word unit means in terms of, let's say, science. If you have a unit of something, you have one, right? So if I'm looking at this circle that I drew right here, and this is the origin, that would mean when we talk about a unit circle, that the length from the origin all the way out to this point here will be 1 unit. The same thing from the origin up, that will be 1 unit. Same thing from the origin to the left, 1 unit, and the same thing going down, 1 unit. That's why we call it a unit circle. So we really could then say that the radius, or any of the radii inside this circle, would be a length of 1, right? All right, so this is basically how we use it. So like I said, if this is out 1 unit, then wouldn't the coordinates of this point be 1, 0? And then the same thing up here, if I go up 1 unit, those would be the points 0, 1. And then out here would be -1, 0. And then down here would be 0, -1. Okay, and again, just going based upon the premise that from the origin to any of these points is a distance of 1. That's why we call that the unit circle. All right, now we're going to end up using this in class tomorrow or the next day, whenever you're in class with us. But we're going to use this in a certain way. So basically, from here, we talk about, remember with the 30, 45, 60 chart, the special angles chart, it corresponded, those angles corresponded with trig functions, sine, cosine, and tangent. And then we found values for, let's say, the cosine of 45 or the tangent of 60. We're going to do the same thing here. So do you remember when we start talking about an angle, this angle right here, starting at the origin, going out here, this angle right here is really 0 degrees. And then as we start rotating around, this would be 90 degrees. And then if we keep rotating around, this would be 180 degrees. Okay, because we're starting here at 0, go 90 plus another 90 is 180. If we add another 90, that would be 270. And then if we add another 90, that would be a full circle, which would be 360. So those angles are what we call quadrantal angles. So 0 and 360 lie on this part of the x-axis, the positive x-axis. Up here we have 90 degrees. On the left we have 180. And then down at the bottom, we have 270. Now, again, like I said with the special angles, you're not always going to, all right, I'm going to say, you are not going to have these written in degrees. So understand that this is like 0 pi. Oops, that's supposed to be a pi. And this is 2 pi. 360 is 2 pi. 90 is pi over 2. 180, remember, is pi. And then 270 is 3 pi over 2. So what's basically going to happen is you're going to be asked for the sine, the cosine, or the tangent of, for example, 3 pi over 2, or pi, or 2 pi, so on and so forth. And the last thing, and we'll do this in class, so you don't need to worry about that right now, but the last thing I want to talk about is how this all relates to finding the cosine, the sine, or the tangent. So what we do is we associate cosine with the x value, and I'll explain that. Sine, we associate with the y value. And lastly, tangent, we associate with the y value over the x value. Okay, so this is really important to know. So let me explain, and I'm just going to do a couple of examples because the rest of it we're really going to do in class. Now, for the sake of simplicity, I will use degrees instead of radians for you. So for example, if I wanted the cosine of 90 degrees, I want to know what that is. Okay, well, I don't have a chart like I did with the special angles, right? The 30, 45, 60 chart, that was real easy to look up. So what I'm going to do is I'm going to say, well, Miss Carter's asking for cosine. She told us that cosine is the x value at 90 degrees. X value at 90 degrees. So you go up here, here's 90 degrees. Which one of these guys is the x value? And you should see that it's 0. So your answer is just simply 0. That easy. Okay, if I ask you for the sine of 270 degrees, let's just say. Okay, so I'm going to say, okay, well, again, Miss Carter told us sine is associated with y. We're talking about 270 degrees, so here's 270 degrees. The y value is -1. So then my answer is just -1. Okay, let me do another one. Let's say I had the tangent of 180 degrees. So then I would go back and I would look and I would say, okay, well, tangent is the y value over the x value at 180 degrees. So here's 180 degrees. I'm going to do the y value over the x value. All right, so that means that's going to be 0 over -1. Now, we never leave it like that. 0 over -1 is really just 0. 0 in the numerator. 0 in the numerator. And if we have any number, anything in the denominator, 2, 5, 100, million, it doesn't matter, will always be 0. Okay? All right, and I lied. I'm going to do one more for you because I want you to see something. What if I asked you for the tangent of 90 degrees? Okay, so I would say, all right, tangent is y, oops, sorry, I didn't have my pointer on. Let's see if I can undo that. There we go. Okay, so tangent is y over x of 90. So I go up here, here's 90, and here's my y value, and there's my x value. So I am going to do 1 over 0. Now, 1 over 0, this is different. This is different than what you have here. When you have 0 in the numerator and a number in the denominator, the answer is 0. When you have the reverse or the reciprocal of that, a number in the numerator and the denominator is 0, just remember that that is undefined. So then you would just simply write undefined, and you can write UND, that's totally fine.